We're almost done with cellular respiration. We will be doing the same procedure for fermentation as we have done before. We'll go over the process, and I'll be asking you questions about what you should remember. If a cell doesn't have access to oxygen, it can't undergo aerobic cellular respiration. Some cells, such as brewer's yeast in your muscle cells, can switch over to another process when there is no oxygen. We call this process fermentation. Fermentation is a way to regenerate NADH so that glycolysis can continue. If you don't continue glycolysis, you don't get the 2 ATPs that are generated by glycolysis. You may be thinking that the cell is wasting the NADH that is generated through glycolysis, but NADH doesn't last very long. It's not like the cell can store it while it waits for oxygen to show up so it can get respiration online again. So here in this diagram, the products of glycolysis, pyruvate, 2 pyruvate molecules, have an acid group that is clipped off. This leaves as CO2. We now have 2 acetaldehydes. They could go to the citric acid cycle, but that would generate more NADH and the cell can't use what it has. The hydrogen from NADH is placed on an acetaldehyde, which regenerates the NAD+. The NAD+ can go back to glycolysis, which then generates 2 ATP. Once the hydrogen is added to acetaldehyde, we have ethanol, the most famous fermentation product. This is why non-distilled alcoholic beverages are bubbly from the CO2. If we are making bread, we want this CO2 to cause the bread dough to rise. Otherwise, you have a tortilla or a cracker. During baking, the ethanol in the bread evaporates off. Your mussels and the bacteria that ferments dairy products have a slightly different process. Rather than clipping off the acid group from the pyruvates, hydrogen is placed directly onto the pyruvate. The hydrogen is placed directly on the pyruvate. This regenerates NAD+ and lactic acid. That way you don't get drunk when you exercise. Also, that's why yogurt and sour cream aren't fizzy. There's no CO2 released. Once again, for both types of fermentation, I want you to know the why, the where, the starting substrates or substrate, the energy used, the energy produced, and the ending product or products.